So today we're going to look at synthetic division and factoring. So here we have the same polynomial, x cubed minus 7x squared plus 7x plus 15. And we are given two different factors, so x minus 2 as well as x minus 5. And with these factors, we're going to go ahead and use synthetic division. So you're going to notice that in x minus 2, what I'm going to look at first is I'm going to take that 0 of the divisor, and I'm going to put it at the left. And then I'm going to go through again, remember to adding down and then multiplying vertically. So we've got 1, then 2 times 1 is 2. Add down is negative 5. Negative 5 times 2 is negative 10. Add down is negative 3. Negative 3 times 2 is negative 6. And negative 6 add down is 9. Now remember that you started off with x to the third, so you drop down a degree. So it's x squared, x, your constant or your number, and then your remainder. Now how you write your coefficients, remember, is x squared minus 5x minus 3, and then plus 9, and then over your divisor, which was x minus 2. Now I'm going to take the same polynomial and with a different factor, so x minus 5, I'm going to go ahead and do the synthetic division. So I've got 5, add down, multiply, add down, negative 2, multiply with 5, add down, gets me negative 3, multiply with 5, gets me negative 15, add down, and that's my remainder of 0. Now again, these are your coefficients to your answer, so when you write it out, you got x squared minus 2x minus 3. Again, no remainder. Now, when I look at these two synthetic divisions, I want to think about which divisor is a factor. And the one that is a factor is the one that was able to divide evenly and divide nicely with no remainder, so that's x minus 5. Now, if you think about what's the significance of the remainder, is that if your remainder is 0, then the divisor is a factor because there's nothing left over. And if the remainder is not 0, then the divisor is not a factor. So let's continue with the same problem, so the one that was on the right, and I'm going to figure out the remaining factors. So remember that here I had the x squared minus 2x minus 3, so that was the answer. So I'm going to write that right here. The x minus 5 was the factor that I was originally dividing using synthetic division. So now if I want to write this in factored form, what I'm going to look at is the yellow. Now, is x squared minus 2x minus 3 able to be factored again? Let me try my box. I get x times x, and then I have 1 and negative 3. That are going to multiply to that negative 3, but they're going to add to get me that negative 2. So this yellow, which was x squared minus 2x minus 3, is factorable, and you get me x plus 1 and then x minus 3. Now don't forget that blue, or that factor that was in the beginning of your problem, and that also has to be part of your final answer. Now I like to call this the freebie factor because it's already given to you in the original problem. So there's your freebie factor, and then your yellow quadratic there that was able to get factored some more. Okay, so here we have a polynomial, and again, we're going to do this with synthetic division. You're going to write your polynomial in factored form. So if you notice here, you do not have an x squared. So I'm going to put a 0 for that missing term. Here is that little freebie factor. It's what is given to you. So that 0 of your divisor is 5. And again, going through synthetic division, adding down, and then multiplying diagonally, and continuing those steps until you get to the very last column, and here you end up having a remainder of 0, which should make sense because the problem is saying that you are given one of the factors of your polynomial, which means I should get a remainder of 0. It should actually divide nicely. So when I write my answer, I get x squared plus 5x plus 4. I'm going to take that quadratic and I'm going to look and I'm going to check. Am I able to factor that some more? So I'm going to try my x and x. two numbers that are going to multiply to 4 but then add to 5. So I got 4 and 1. So again, here is my freebie factor. I have the x minus 5, so that's going to stay in your answer. And then the red is coming from the yellow quadratic that I had originally factored. All right, here we go. Let's continue on another example. You're given a polynomial and again one of your factors. So if we tell you it is a factor, then your remainder should be 0. So your 0 of your divisor is 7. Again, add down and you're going to multiply across. So again, continuing the same steps. Add down. And then you do get 0. Now you're going to notice that with the 0, again, your remainder, right? We are given a factor. I should get a 0. Now you get x squared, and then your 0x, you don't have to put it, but again, that's imaginary there, and then minus 9. So when I look at x squared minus 9, I ask myself, can I factor more? So I'm going to try my box. And I got negative 3x and positive 3. Okay. So I've got x minus 3, x plus 3, and again, that freebie factor of x minus 7 is going in the front. Again, if you can recognize the difference of square patterns, you don't have to do your area model. But if you need that extra, again, that check for your factors, is it factorable or not, you can, of course, do the area model or the box method. So here are some things for you to remember as you do synthetic division. Remember to write zeros for any of your missing terms. And then also when you factor in your final answer, make sure to include that freebie factor. So if we give you and provide you with the factor and we tell you that the factor you are given of your polynomial, make sure you include that in your final answer. I hope you found this video helpful and you're able to use synthetic division along with factoring. Thanks for watching and have a great day.